Well, once we learn estimation procedures in binary regression models, the estimation of auto regression models, in this case, proportional odds model, becomes relatively straightforward. So what we're going to do is to figure out individual probabilities. And as we talked about and derived, the probability for y equal to n given observed data of covariates and parameters can be expressed in this form, a difference of two cumulative density functions. And if the error term in the structural model for y star, that is the latent continuous variable, follows a standard logistic distribution, then we have a order logit model. If the error term follows a standard normal distribution instead, then the cumulative density function is going to become the cumulative density of a standard normal. What we're going to have is a order probing model. Okay, so here is this individual probability. What we're going to do, if you recollect what we did for the binary regression model, that is, we want to express the probability of observing the data. In this case, actually, the conditional y, that it observed y, and this ordinal response variable given x can be expressed as a quasi probability, that is likelihood, as a function of product of individual probabilities assuming IID, okay? IID, that is identically independently distributed random variable. Okay? So we could have a couple possibilities, right? Here for probability. So for y equal to 1, we have this probability and can be expressed as a difference of this two. And for y equal to 2, 3, 4, 5, till y equal to m and y equal to the highest response level. Next step is to express the likelihood, that is quasi probability, as a product term of this individual probabilities, And we have this function. So what this function does is it checks into the observed data, particularly observed y, and see the values of y, then construct the function accordingly, right? The difference of these two cumulative density function, then multiply through all observations, okay? We get a likelihood function. And this likelihood function, because it is a product, so mathematically it is intractable, or it is not very easy to deal with. So what we're going to do is we take a natural log of this likelihood. Well, that turns into a log likelihood function. And next step is to apply a numerical method in maximum likelihood estimation and find maximum likelihood estimates of this taus. And taus are what is called auxiliary parameters. They're useful for estimating the model, but they're not that useful for interpreting the results. At the same time, we're going to figure out beta. Okay? And at the same time, we're going to calculate the variance covariance matrix of this maximum likelihood estimators, which turn out to be inverse of information matrix, or a negative of the expected Hessian matrix inverse.